这位讲话的是Tom，Tom 是已经在 Google 工作了4年了，然后他是我们这个 App Engine 这个产品的一个最开始的一个人物。Tom 这次是第一次来中国，所以请大家热烈的欢迎。
Thanks. I think I'll just use this mic. Is this working? Hello? All right. So yeah, my name's Tom Stocky, and I'm here to talk about Google App Engine. One thing is if this is an intro talk, so if there's anyone here who has used App Engine, especially if you've deployed an application, this might be a little bit basic for you. So maybe just check email or go to another session, and if you have specific questions, you can catch me afterwards. But basically, this is a pretty high-level talk, and I'm just going to go into kind of an introduction about Google App Engine. So as you heard in the keynote, Google App Engine is a way to run your web applications on Google infrastructure inside of Google's data centers. Over the years, Google has invested a lot of money in its infrastructure, spending millions of dollars a quarter building out machinery. And Google App Engine is a way that you can run your web applications on that infrastructure. So I want to start out just by talking about the process as it exists today to run even the simplest web app. To start out with, you have to get machines. So you're either buying physical machines or virtual machines, depending on what your interest is. Then you have to configure those machines. You're configuring Linux, your web server, configuring your SQL databases, getting all of those things to work together to the point where you can actually run a web application. And then once that's done, you actually write the code for your application. But the real problem, like even after if you get all that done, you spend a few months, you pay for the infrastructure up front, and you get your app deployed. The real hard part comes is if it becomes really popular. And if your app becomes popular, then you have to deal with scaling your application. And at some point, your database, just the user table alone, will become too big for a single server. And so you'll have to start sharding your database. You'll have to replicate the data across multiple servers. You'll have to deal with load balancing. You'll have to deal with what happens if a machine breaks, or if a disk crashes, or if memory goes bad. And all of these things are hard problems, and they're things that at Google we spend a lot of time trying to fix for our own applications. And we found, actually, we talked to a lot of developers, and we found that as much as 20% of their engineering time was being spent on system administration and maintenance, which means if you're a startup and you have five developers, that means one whole person is spending all of their time dealing with machines. So App Engine is meant to be a solution to this. The idea is that you write some code, you upload it to our servers, and we run it for you. You never have to worry about scaling your databases. You never have to worry about scaling your app servers. It just works. And as your app gets more popular, the infrastructure can help support it. And we designed it with 2 design goals in mind. One, we wanted to make it easy to start. So from that time when you have an idea for a web application, to the time when you're able to get that application live on the web, we want to shorten that and make it as short as possible so that instead of spending 3 months building out infrastructure, you can think of an app, write some code, and get it live very quickly in a matter of hours. And the second is we want to make it easy to scale. So assuming your application gets popular and you have tens of thousands or hundreds of thousands or even millions of users, we want to make sure that your underlying infrastructure can support that increased load. So at this point, with that preamble done, I just want to walk through a sample application. And this is a very simple app. It's just a guest book application. So users can come to the site, they can basically write messages, and then those messages show up to all the users. And I'm going to walk through the different components of the app and then show you what it looks like. So the first thing that every application needs is a configuration file called app.yaml. And there are a few important components to the configuration file. The first is the app ID. The app ID is really important because it's the unique identifier for your application. And actually, the way you get one is when you sign in on the web, you sign up for an application ID. If it turns out that it's already been taken, we'll maybe suggest some other ones, but eventually you'll get an app ID, and that's the one that you'll put in this configuration file. And the app ID is actually what will end up being part of your URL when you deploy the application. So whatever you decide on your app ID, it will be appid.appspot.com. So it's important to choose this one carefully. in this case, because we're creating a simple guestbook app that just basically posts messages, I chose the app ID message board. The second thing is the version ID. In this case, it's 1. What the version ID means is when you have a bundle of files, that's this configuration file and whatever your code files are, you can give that bundle a version and then deploy it. And let's say if this is version 1, you can also deploy version 2. And you can choose in the administrative console, you can choose which version you want to be live to users, and then maybe you can use the other one to just test yourself and see if it works, and then switch to version 2 when you want. It's meant to make it easy to do deployment and versioning, and also make it easy to do rollbacks in the case that maybe version 2 has some fatal error. The third is the runtime ID. At this point, it's basically the language that your application is written in. Right now, App Engine supports Python only, but we are working on other languages. So for all your applications right now, this would be Python. And then the bottom part is the URL map. And what this is doing is basically you're defining regular expressions for what the user's typing into the URL and mapping those to the code to support that. So in this case, I've just done a regular expression that's just .star. So that means everything that's in the URL for this application goes to one file, which is demo.py, which is a Python file. So let's talk a little bit about demo.py. One of the important components of your Python file is going to be the data model. So in this case, it's a pretty simple data model. You can see I've created a model class, and I've called it message. You can, within your data store, it's a little different than a traditional database. It's schemaless and it's object-based, which means that instead of defining a schema for your tables, for your SQL tables or something, instead you're just defining types of entities. And in this case, I've defined a message entity. And for each message entity, it has 3 fields. It has who, the person that's writing the post. It has content, which is what the actual message is. And then it has a when field. And you can see for the when field, I've set auto now add to true, which means if I don't define the when field when I'm putting the message entity into the data store, it will get assigned automatically to the current time. And the reason, and so I'm going to talk later about some of the differences between SQL and our data store. But one thing that's interesting is that I could put in a bunch of these entities, these message entities, and let's say later I wanted to add another field, maybe a where field, to say the location of the user. I could do that, and I wouldn't have to do a schema migration like you might be used to if you've used relational databases or SQL a lot. Okay, so now that I have the data model, I know the kinds of entities that I'm going to be dealing with. And so another part of the demo.py file that's important is the request handlers. And so here I've got handlers for get requests and post requests. The top part for the get requests, basically what I'm doing is pulling all of the messages from the data store, taking the most recent 100 messages, and then I'm just displaying those on the page. So, excuse me. So I'm taking the messages, bundling them into a values list, and then I'm sending that to an HTML template. Sorry, this is a lot of talking for me. And so I'll go into the details about the template in a second. But the other important thing is the post request. So with the post request, what I'm doing is I'm taking the post data that I'm getting from the user, and I'm pulling out the who field, and I'm pulling out the content field, and then I'm creating a message entity, and I'm putting that message entity into the data store with the message.put. And then once that's done, I do a redirect back to the page itself, which will trigger the get response, and that will just show all of the messages, including the most recent one that just got posted. Okay, so the template. What you're seeing here is this is a Django template. Django is an open source web framework for Python. There's a lot of frameworks out there. Django is a good one, and it's nice because it actually works with App Engine out of the box. But there are a lot of other frameworks, and you can use whichever one you want. The important part of this template is, on that last slide, you saw that I was bundling the messages and sending them to this template. So here what I'm doing is I'm looping over all of those messages, and then I'm just creating a line for each one that just has the message, who it's from, and when it was posted. And then at the top of those, I have a form so that people can create new messages, and post them. So that's basically, that's basically enough to have a very simple application and be able to deploy it. So once you have an application, you have this bundle of files. Basically, you're going to have a Python file. You'll have some static resources, maybe like a CSS file or some image files. You'll have that app.yaml file. Once you have that bundle, you need to upload it to Google servers. What you see here is an application for Macs, for the Mac, that allows you to do that. We also have a command line utility that works for Linux, Windows, and Mac. And so once I have deployed it, it will show up at the URL I mentioned before, which is basically going to be yourappid.appspot.com. And in this case, because my app ID is messageboard, it will show up at messageboard.appspot.com. Okay, so now that you've seen a sample application, let me just walk through some of the important components of App Engine. The first is our scalable serving infrastructure. This picture is a joke. It was taken from the 1950s. I think it's an IBM research lab or something. This is not what our data centers actually look like. But basically, the idea behind this is that we have a number of fault-tolerant servers that when you deploy your application gets deployed to a number of these servers. And depending on how much usage you get, that will affect the number of servers that your application lives on. So in this way, resources are allocated fluidly based on how much usage your app is getting. The second important component is our distributed data store. And this is based on a scalable storage system called Bigtable. Bigtable is something that there's papers published online if you're interested in learning more about it by the Google engineers who are behind it. But the basic idea is that this was a data store that was designed from the ground up to be distributed, so to distribute across multiple servers, multiple data centers. And because it was designed in this way, it means it can scale very effectively. And this is, and like I was saying before, there's a distinction between Bigtable's model and a standard SQL relational database. And that's that it's schemaless and object-based. This makes it easy for flexible and rapid development. But it does mean that, for example, there's no joins. And if you're used to SQL, you've definitely used joins a lot. There's a good reason why they don't exist here, and that's because it's actually pretty hard to get joins to scale effectively to massive amounts of data. So while you lose functionality like joins, what you gain is the ability to have a data model that can go to thousands of disks across thousands of machines. And while it may be a little bit of a learning curve to learn this new model, we think you might actually grow to like it. Certainly at Google, the engineers at Google who have built all of our products have grown to like it, and it's actually, this is what's based, like all of Google products, search, maps, etc., all of them use Bigtable. And it has really useful functions, features like queries, transactions, and composite indexes. So I showed you this model class before. This was from the sample app. I want to bring it up again just to show you what a sample query might look like. And so, like I said, this isn't SQL, but we've created something that's similar to SQL called gQL. And so here you can, if you're used to SQL, this might look similar. I'm just selecting all of the fields from message entities where who equals Brett, which is one of the authors, and I'm ordering it by when it was posted in descending order. And so while it's not the same language as SQL, we're hoping that this maybe eases the transition for people who are very familiar with that. So the third component is the Python runtime and libraries. Like I said before, Python is our first language, and we support the full Python runtime, about 95% of the standard libraries. We had to take a few of for security reasons, we had to take some of the system calls out that relied on native code, but it's still 95% of the standard libraries. And like I said, it was our first language, so we will have other languages in the future. The fourth component that's important to mention is the software development kit. What this allows you to do is you can download the SDK, you can run a version of App Engine on your local machine, and it emulates all of the APIs on App Engine. And this means that you can do most of your development and debugging locally on your own machine. And then when you're ready, you can upload it to Google servers. It's really, the reason we created this was when we first started building App Engine, we found it was pretty painful to have to deploy the app, then do some debugging, and then deploy another version. There were at least a minute of lag. And this way, this really makes that code compile debug cycle very, very short. And the last thing to mention is, of these 5 components, is the web-based admin console. So once you have your application running live on the web, running on Google servers, this is basically a window into how that application is doing. So you can get usage stats and charts. You can see how much resources you're using. You can see the popular URLs that people are using and also where the most prevalent errors are. It also gives you a way to download your application logs if you want to do some analysis there. You can look at your data store through a web-based interface as well and make some adjustments there if you want. And there's other administrative settings that you can use here. So with those 5 components, I just want to mention some of the APIs that App Engine exposes. The first is Memcache. This is a coherent caching layer so that for your frequently accessed pages or queries, it will reduce the response times for those. The second is an email API. This lets you send email from within your application. The third is, it's called URL fetch is the API name. It's to make arbitrary HTTP requests. So if you want to pull in content from another website, or most of the times what you would use this for is to pull in like an Atom or an RSS or an XML feed as a way to access some other service. There's also an authentication API. So you don't have to use it. If you want, you could use something like OpenID, or you could roll your own authentication system. But it's there if you want to do it in a painless way, which is just you can take advantage of Google accounts. You don't have to deal with user provisioning or forgotten passwords or security or any of those things. And the fifth is one that the last one that just came out a couple weeks ago, which is an image manipulation API. That lets you take in large image files, and you can scale, rotate, resize, do whatever you want on the server side, which is pretty useful. And it's something a lot of people were asking for. So now that I've told you how great App Engine is and why you should use it, I do want to emphasize that we only launched a couple months ago. This is still what we call a preview release, which means it's still missing some important features. But we wanted to launch it early so that we could get your feedback early, and so that we could use that feedback to influence the product design decisions we make down the road. So we hope you'll try it out and give us feedback. In the preview release, it's entirely free to use. So your application gets access to 500 megabytes of storage, a lot of bandwidth. Basically, for a typical application, this will equal around 5 million page views per month. And this is all free. And when we initially started, we had to limit it to 10,000 developers. And we had a wait list of 150,000 developers who were waiting in line to use it. And so as of a week ago, we opened it to everyone. So now if you want to use it, you can sign up right away and start using App Engine immediately. And it's important to mention that it will always be free to get started. So we do have plans later this year to allow you to use more than this amount of resources, so that you can purchase, if your application is big enough to get more than 5 million page views a month, allow you to purchase more resources in terms of CPU and bandwidth and storage. But even when that happens, even when we do have the ability to charge, this amount right here will always be free. So every month you'll still be getting those about 5 million page views per month. And when we do charge for resources, you will only pay for the resources your application uses. So it's not like the standard model where you have to buy a whole machine or anything like that. So what's next? I mentioned it before, more languages, and I just talked about purchasing additional capacity. Some of the other important features that are missing, right now every HTTP request that's ingoing or outgoing is limited to 1 megabyte, which means if you wanted to have a file if you wanted to have an application that let your users upload large files like videos, it wouldn't be possible. So we want to get rid of that constraint and enable large upload and download support. And the other is offline processing. Right now, all of the processing that happens in your application has to be the result of an HTTP request. So the user has to make some request, and then you do some computation and you return a response. We want to make it so that you can do computation even when that's not, when there are no user requests. So if you wanted to do batch processing of large like logs analysis, or if you wanted to do some physics equations, I don't know. We want to make sure that that's possible as well. So that's basically it. I think we do have time for questions if you have them. But if you want to learn more, a lot of information is on the web at code.google.com. At the URL you see, or if you want, a simpler URL is just going to code.google.com, and then in the upper right-hand corner there's a language drop-down, and you can just choose Chinese, and it will give you the equivalent of this page. So thank you.